Everyone, in this video, let's take a look at question 198, house robber on Leetcode. This is part of our blind 75 list of Leetcode questions. So, begin. In this question, you are a professional robber planning to rob houses along a street. Each house has a certain amount of money stash, and the only thing that's stopping you from robbing each of them is that adjacent houses have security systems, and it will automatically contact the police if two adjacent houses were broken into on the same night. Given an integer array nums, representing total amount of money, we want to return the maximum amount of money you can rob without alerting the police. Okay, so let's take a look at the examples that we have here. And I will just paste them over here. Okay, so it looks like in this first example here, we have 4 houses, and looks like what we want to do is rob house 1 with money 1, and then rob house 3, and that gives us a total of 4. Looks like here we want to rob house 1, which is 2, and then 9, and then rob house 5, which is 1, to give us 12. Okay, so from the examples, it looks like we're just skipping houses, right? But actually, it doesn't seem like we can do that, because let's just consider a simple example like 2119, right? In this case, the best thing to actually do is rob house 1, and then actually don't rob like any of these, and then directly rob this last one. Because if we were to rob 2 and then 1 here, we can't rob this 9 one. Even if we were to like skip this 2 here and rob this and then rob this, well, that would give us 10. It wouldn't give us 11. So that's kind of like the constraint over here, that we can't just arbitrarily just skip houses and assume that's the best. So basically here, I'm thinking what it seems like is like we have a couple of choices, right? Like let's say we're on I'll just make some random houses here. Okay, so let's say we're like on house N, right? We're over here. We're on house N. So up to this point, let's assume we already like know the correct answer, right? Like we already know the best answer up to this point. Well, if I'm on house N, then it looks like I kind of have like 2 choices, right? Either I can. What can I do? So let's assume I want to rob house N, right? So if I want to rob house N, well, if that's the case, then basically I want to take the best answer until 2 houses behind, right? Like this house, I want to take the best answer. Let's just call that house I. So basically, what I can do is I can find best answer till house I, and then add house N, right? And we're allowed to do this because up till house I, well, it's fine if like this was robbed. It's fine if this wasn't even robbed. But basically, what I want to do is I want to find the best answer up till here, and then simply add this one. And we're allowed to do this because this is like we're skipping over one. So this is allowed. What wouldn't be allowed is like we wouldn't be allowed to do this. Like we wouldn't be allowed to take the best answer up till house J and then like add on N, because it's possible that we robbed house J, and then if we're adding on N, then potentially like we rob both of these, in which case it alerts the police. So the first scenario is like if we want to rob house N, then we basically find the best answer until house I, which may or may not have been robbed. We don't know if it's been robbed. We just know that this is the best answer until house I. And in this case, like for example, let's assume that this was a 1. So in this case, and maybe this was like also like a 1. In this case, it looks like the best scenario would actually be robbing this and then robbing this, right? Because that would give us 6. Whereas if you did it like any other format, this would still give you 5. So in this case, this array at I would actually be 6 because that's the best house. That's the best amount of money you can get so far. So that's the first scenario. If you want to rob house N, then you find the best answer till house I, and then you add on house I. Otherwise, I guess, if you don't want to rob N, then basically we just take the best solution so far, right? And the best solution so far would be, well, whatever is the previous one. And again, this house might have been robbed, this house might not have been robbed. But basically the idea is that up till this point we have the best solution. So we just take answer in house J. And it looks like that's basically like the solution here. So like a simple recursive, which we might be able to optimize using dynamic programming. But let's kind of just see this out and see how it works. So let's maybe handle our base cases here, I guess. So what's kind of like the base cases before we go ahead and do the recursion. So let's see. Well, nums is a list, right? So if length of nums is equal to 1, right? If length of nums is equal to 1, well, in this case, the only house we can rob is the existing one, right? So like the first one. So we would return nums at 0. Let's say it is 2. In this case, well, it would have to be like the maximum of the first two, right? Because we can't rob both of them. So it has to be the maximum of the first two elements, which is nums at 0, nums at 1. Otherwise, in this case, let's just go ahead and recurse and we figure out our solution. For our self.helper, and so this is a recursive method. So let's see, what do we need? Well, we need the nums array, obviously. And one more thing is, well, we need an index, right? We need the index I. Well, basically like where we are in the where we are in the array, basically. So now, how about, what do we want to do here? So do we want to start off at the end? Yeah, so it makes sense that we start off at the end, right? So we'd start off at the end, and then basically to figure out the answer, we would keep recursing backwards and backwards. And then once we arrive at our base cases, then we can basically figure out what the answer should be. So let's maybe kind of just start with that. So let's see, how would this work? So what are our base cases here? And I might actually be able to remove this entirely, but let's see what we can come up with. So over here, if I'm starting at the very end, right? If I'm starting at the very end, yeah. If I'm starting at the very end, then let's see. So my base cases would be if I is equal to, let's say it's equal to 0, right? If I is equal to 0, then we'll just return nums at 0, right? Because that's like the best house you can rob so far. If I is equal to 1, then we want to return, I guess, maximum of nums at 0, nums at 1, right? Otherwise, what do we want to do? We want to return, well, there's two cases, right? So we can do like case 1, and then we can do case 2. In case 1, we basically rob the house, right? We rob the existing house I. So in this case, we want to take the answer of self.helper nums I minus 2, and then we want to add in the value at nums at I. In the other case, we simply want to take the answer of nums at I minus 1, because we don't want to rob the other house. And so then what we can do is we can return the maximum of case 1 and case 2. And so then this should be a working solution. So let's take a look at this. And what can we pass in here? So what we will pass in is nums, and we can pass in length of nums minus 1. And we might actually be able to just completely remove this, right? Because our recursion should take care of it. So let's maybe try and run a few test cases to see if it works or run into any problem. So I need to pass in I. So here, I actually should, here should be I minus 1, and I should pass in nums over here. So that should be what we pass in. So let's take a look at the test cases now. And we get the correct answer. And let's go ahead and submit it to see if we get the correct answers. We might get a TLE, which is expected here, but that's because we're using recursion and we probably don't need to. We can optimize it. So let's just make sure that, okay, so time limit, perfect. So at least we know our approach is correct. Now, the next thing we can do is basically let's do memoization. Memoization, it's very easy in Python. Basically, we'll have a memo here, and then every single time we'll do memo at I is equal to nums at 0, and then we can remove this. We can do memo at I is equal to this here, and then we can remove this, and then we can actually do if I in memo. We'll return memo at I. Otherwise, we will do something like this, right? And then this one will be stored at memo at I is equal to this, and then we'll just return memo at I. So let's actually go ahead and try this out. And I'll try this out, first of all, on our sample test cases. And I'm missing memo, obviously. I always forget. So let me try it out on our sample test cases. It should work. And we'll try it out on this TLE one that we got. And so this should also work. And now let's go ahead and submit it. Perfect, so it works. Now, one more optimization we could do here is instead of memo, let's just do dynamic programming. So if we have the memoization case, it's very easy to actually do by dynamic programming, because the way it works is if we just go ahead and uncomment this out, then now we can just prepare array, right? So array will be, well, we can set it to equal 0 times length of nums, right? And then we'll just set these two fields is nums at 0 and array at 1 is this thing here, right? Okay, cool. And then basically, let's just go through it. So for I in range, looks like we're starting at 2, length of nums. Then array at I is equal to what? Well, array at I will be the maximum of these two cases here. So it'll be the maximum of, actually, it looks like we can just copy this. So let me just go ahead and copy this. So we'll copy this in. So instead of self.helper, all of this, we would just do array at I minus 2. And then here, we'll just do array at I minus 1. And then here is the maximum case 1, case 2. And then in the very end, we will just return what is the best answer, like at house, the last one. So here we will return length of nums minus 1. And that's basically all there is. So let's go ahead and run this. And we'll submit. Perfect, it works. So in this question, it looks like the time complexity is O of n. We're just going through the list. And also space complexity is also O of n because we're storing it in dynamic programming array. All right, thank you for watching.